What's up, YouTube? Welcome to this next episode on So You Think You Know C Sharp. In this episode, we're going to be looking at constructors. Constructors, you say? Yes, constructors. I want to take you through some of the bases of what constructors are, how they operate behind the scenes, and the why, and particularly also one of the issues I had when I came to C Sharp from other languages, some of the confusions I had in this regard. I still use some features or some concepts that are considered bad practice in C Sharp. And I'm going to take you through that because that's something I sort of grew up with, if you will, with my object-oriented programming experience. I'm going to be talking about some of those things as well. So there'll be some C Sharp, there'll be some IL or intermediate language code that I will show you, and we'll kind of go back and forth to see the behind-the-scenes implementations of C Sharp constructors and static constructors. So just some background information. Before I did C Sharp, started with C Sharp, which was way in the beginning, like even before C Sharp was publicly available. And before that, I was doing Delphi, and I did Delphi for about 8 odd years exclusively. And before that, C++ and a whole host of other things. What I'm getting at is I had certain background from C++ and Delphi. So when I came to C Sharp, things were a bit confusing. And the reason is that in Delphi, we have inheritable constructors, or constructors are inherited. They can be virtual, so you can override them in descendants. And in C Sharp or C family language, typically we don't have that feature of inheriting constructors. And in C family languages, things kind of go backwards, if you will. They sort of seem forwards today after all these years of C Sharp. But when I first came to C Sharp, they seemed a bit confusing. And of course, between C++, C Sharp, and Java, there are differences. So if you come from a C++ background or you come from a Java background, you will find C Sharp constructors to be slightly different. Now, I think it's the right implementation. One of the motivations for C Sharp was to eliminate some of the weirdnesses from C++ as well as Java. Java's motivations might have been similar in that they were trying to eliminate some of the things that we find in C++, mainly having to manage or memory management in C++. So in C Sharp, the motivation was to improve on Java and C++, and I think they have done that. Nonetheless, it was a bit confusing. Now one of the reasons I bring this sort of history up is that maybe interesting tidbit for some of you. Anders Hejlsberg, he's the creator of Object Pascal, Delphi, C Sharp, and TypeScript. So this guy is phenomenal. His language design capabilities are just outstanding. I love the way he designs languages. And of course, when I came from Delphi to C Sharp, I would expect to have been doing the same things. And I couldn't understand why they moved inheritable constructors and the ability to override constructors and descendants. Of course, in keeping with C family languages, I think they did the right thing with C Sharp. But the way I used to think at the time was with these ideas of having inheritable constructors and overrideable virtual constructors, so you can override them in descendants. And, you can imagine all of it design kind of centers around that feature or that capability. And in C Sharp, I sort of lost that. So when I came to C Sharp, it took me a couple of days of trial and error and playing with, the different permutations to truly understand how C Sharp constructors worked, and then how I would use that knowledge now in terms of designing my classes. Now, some of the things we talk about today will only matter to you if you are designing classes, not so much when you use classes necessarily because you're just newing it up, but it's when you're designing classes and specifically polymorphism. I'm not talking polymorphism with interfaces. I'm talking about polymorphism, the true polymorphism, which is with classes. And if you're designing polymorphic classes, then you're invariably hitting upon this constructor thing. All right. Okay. Now I'm going to start from the beginning for those of you who are not very familiar with constructors. Nonetheless, this is not a full-on constructor kind of tutorial. There's an assumption I make that you do know constructors. You just haven't gone into the depth of constructors. So there's going to be starting off simply and eventually get to the crescendo of virtual methods from constructors. All right. I'm sure there'll be enough for a lot of you to learn, and I hope I'm able to do a good job. So let's get started. So what we have here is just a simple base class, vehicle base. It's got these 3 properties, and I've intentionally left them as just members instead of properties because there's some things I want to be able to do in the course of this demo that I need them to just be members rather than properties. Not that there's any difference, it's just easier to manipulate. And then we have a constructor here that writes out to the console. It's in the vehicle base constructor, and then prints out the details, which is nothing but the string concatenation of the make, model, and year of the vehicle. Then there's a drive method that calls on start engine and shift into gear, which are both, in this case, both are abstract, so they're virtual. Sometimes I'll say virtual, I mean abstract or virtual, they're one and the same thing. And then we have one descendant that descends from vehicle base, and it sets up the make, model, and year to be a Toyota Land Cruiser and 2020, and also writes out to the console that this is in the vehicle Toyota's constructor. So now keep in mind here that the base class's constructor is calling the sprint details method. The descendant per se has no call to anything. So what we're trying to do is set up all of this information so by the time it calls the print details method, we should see the proper information. So now those of you who already know this is not going to work as expected, then please hold on, because as we get further into this episode, things will get a little more interesting, complicated, confusing, and so on. So I'm just going to run this application. And as you can see here, the first goes into the vehicle base constructor. CTOR is the IL instruction for constructor, so I'm just using that here, and we'll see a lot of this moving forward. So just keep in mind, CTOR means the IL instruction for constructor. And then we have the make, model, and year. They're sort of nulls and 0. And then finally we go into the Toyota's constructor. So even though we were trying to create an instance of Toyota, we are actually, from the Toyota's constructor, apparently, we are going to the base class's constructor first, calling print details, and only then actually doing this part. And this is one of the features that you have to understand if you're working with constructors and designing classes. Typically in C family languages, that's how it works. Of course, C# is also slightly different from C++ in certain ways, but here's how it works. If you have, let's say, classes A, B, and C, where A is the root, then B is a descendant from A, and C is a descendant from B. If you were trying to construct an instance of C, which is the sort of the most derived class, then before C can be completely initialized, it has to go through the code for A, and then B, and then come to C. Because C is nothing but the sort of the combination of A and B in terms of inheritance. So it's not like it's, even though it's calling the constructor of A and B and then coming to C, it's not like you have an instance of A and then you have an instance of B and then you have an instance of C. It's just that C is really the composition of, not composition, but the conglomeration of both A and B. So in order to construct C, it has to have done everything that it is required for A to be initialized correctly, B to be initialized correctly, and then finally come to C's constructor to then initialize C. Now that might seem a little backward sometimes because, of course, who would think that would happen? Especially when I'm looking at this constructor here. First of all, I don't call the constructor myself. So how the heck is that happening? And 2, this code is not even running. And it runs the ancestor classes, constructors, and the method implementation, the constructor implementations before it even starts on the first line of the constructor of the class you're trying to create. Right now, in C# we have what we call a default constructor, which is a constructor of parameterless constructor. This is the constructor that is typically used, but if you don't define a constructor or a default constructor is defined for your class at compile time. So whether you like it or not, if you've not defined a constructor will be defined for you at compile time, for your class, sorry, not for you, for your class at compile time. So the default constructor will be there no matter what. Now, if you define a constructor of your own, whether it's the default, meaning parameterless constructor or another constructor with a parameter, then of course the default constructor will not exist. So the only time the default constructor exists for your classes will be if you didn't define one and you haven't defined any other constructor, or if you define a default constructor of your own and also define other constructors, right? So the one will be created for you. The second thing to keep in mind is because we are in C#, in order to create an instance of Toyota, we have to have created, not an instance, but have to have initialized like the A, B, and then the C. There is inadvertently a call to base like that. Even though we don't see it, it's there. And similarly, vehicle basis constructor also has an ancestor, which is object. So it's really going to be like that, right? That's what's really happening behind the scenes. Now I'll take this out, the call to the base constructors. Now I want to show you something. So now I'm taking this out. I'm going to build this application, and I'm going to run ILSpy. You can run ILDASM as well. I just like ILSpy only because it's got color highlighted code that you're going to see here. I'm going to open up the assembly, and then I'll find my vehicle base. So let's go into vehicle Toyota, and let's look at this CTOR. CTOR, as I said, is the IL for constructor. For static classes, for static constructors, it is CTOR, and for instance constructors, it is CTOR. We're going to be doing both in this episode today, so just keep that in mind. So I'm looking at the instance constructor here, and you'll see a few things that might be weird. The first thing it does, it calls into the vehicle basis constructor, and then it comes into setting up the, calling out the, let me look at that here. And then it comes to this console.write line, and then setting up all of the different members, that is the Toyota, the Land Cruiser, and the year 2020, right? So first it calls the vehicle basis constructor, then it does the write line statement, and then it does all of this. Now, if you go into the vehicle base and look at its constructor here, you'll see that it is in turn calling the objects constructor, its ancestor. Right? So it's going to happen. A constructor needs to be called. Now, if a ancestor class has multiple constructors, you can choose which constructor you want it to call by explicitly putting in the base call. But if you don't, it's going to go find a default constructor. Now, if your ancestor does not have a default constructor and you've not explicitly called an ancestor's constructor, you're going to get a compile time error. For example, let's say my base class here doesn't have a default constructor. Let's say it takes in a variable. And over here, the idea is to set the make to the make variable, right? At this point, this class is going to see an error. It says there is no argument given to the corresponding, it says there is no argument given that corresponds to the required formal parameters of this constructor with the string argument. So if your ancestor does not have a default constructor, then you have to call one of those constructors explicitly. So here we could do something like base and pass in a null, or we could say let's pass in Toyota here. And then what will happen is if you were to run this application now, because we have set up the make to what has come in here first, but it's coming from the base class, you will now see Toyota being printed out when we do the print details method here. So let's check that out. So if we look at this make, it's now Toyota, right? So let me just run this the normal way here. So you can see here now, it prints out Toyota model is still null, and here is 0 is the default value. So far so good. Okay, this is the simple part. This is kind of like the thing you would just expect, and it's something you have to learn, and once you learn it, it's sort of easy to work with. All right. Now things are going to get a little more confusing or interesting depending on how you look at things. If you love puzzles, this is interesting. If you don't like puzzles, this is confusing. All right. So now what I'm going to do is I'm going to set up, let's say over here, just in the base class here. Let's say I set up, instead of Toyota, I say Honda, let's say. And Acura. There's a Honda Acura. I don't know. And the year, let's say, is 2019. All right. So now these are called member initializers, meaning not only we have declared a member, we are initializing the member itself in inline, right? So these are called instance member initializers or just member initializers. And we also have the static version of that, static member initializers. We look at those as well. Right now we're looking at the instance constructors and the instance member initializers. So let's see what's going to happen here. And let's remove this for now. Just going back to the original here. So we'll also take this out. We don't need that. All right. So all I've really done from the original setting is we set up the values for we've initialized the members. All right. Let's take a look at running this and see what the output is. So you'll see now that we have Honda, we have Acura, and we have 2019, right? So this is set up, even though it was never actually called. So the question becomes, at what point do these member initializers run? In C#, we have a guarantee that all member initializers will be run before the instance constructor. Similarly, all static member initializers will run before the static constructor. Not that we've talked about static constructors yet, but that is the guarantee we have from a C# design standpoint. Member initializers will always run before any instance constructor. Okay. But let's see how that actually is achieved. So I've just rebuilt the application, and I'm going to look at ILSpy again. And ILSpy, I just need to reload this exe. And then go back here. And if you look at the base constructor now, you'll see a few things. This is the constructor for the vehicle base class. And in the constructor itself, the value of Honda is being assigned to make, the value of Acura is being assigned to model, and the value of 2019 is being assigned to the year. And then it calls the object constructor. So what's happening is member initializers are run even before calling the ancestors constructor, which is pretty cool. It's also a big difference from, let's say, I think Java. In Java, those will not be initialized. They'll happen afterwards. So member initializers will be initialized after the ancestors call, right? Or in C#, the ancestors constructor call is being done after the member initializers have been called. All right. Now, along with this member initialization tricks here, also keep in mind, if you had multiple constructors, let's say I have another constructor here. And let's say I take in one argument. What's going to happen? So what's going to happen, going back to IL and reloading this exe, going to the base. So now you see two constructors here. This one, which was the same. So these members are being initialized here before the object constructor. And in the other constructor, we're seeing the same thing. In other words, this is being repeated in every instance constructor. So this sort of thing is going to cause a lot of code bloat. If you have a lot of member initializers in your classes and multiple constructors, then the same code is going to be repeated over and over again, right? Now, member initializers are a really good thing. You should use them to the extent that you can and need. So don't stay away from this feature. However, the reason this is happening is because you're doing something else wrong if you're doing this, right? The idea with constructors is if you have more than one constructor in a class, you must always chain constructors. Don't have constructors doing completely different things. You must chain them. So the way that looks is like this. So let's say I have a constructor here that takes in a make, a model, and a year. Like that. I could have, it doesn't make sense to have a public constructor on this class because this class is abstract, right? So because this class is abstract, it has no meaning to have a public constructor, which is what I'm seeing over here. It says, change the visibility of this constructor to protected. All right, now, so by chaining constructors, what I mean is this. Let's say this is your constructor that takes all the arguments possible, right? And you have another constructor here, and I will talk about the default here as well. we have another constructor that takes just the make. So the way to do this is you want to change these constructors. So you want to call this, passing it the make as one argument, but you could say null for the others, or 0, null and 0. Right? Rather than repeating the code, you're calling this constructor. This also needs to be protected. And let's say over here, we do the same thing. We call this. And over here, we'll just pass in null, and 0. Right? So we got 3 constructors and we got 3 member initializers. I'm just going to build this application again and go back to IL, reload. And then look at the constructor for the base again. So there's 3 constructors here. Look at this constructor. It's not repeating, right? It's simply calling vehicle base is the other constructor with this call. So it's not actually repeating the member initialization here. So these member initializations are not being repeated. This one does have it. And this constructor, the one with the 3 arguments, does have all these members being initialized before calling the objects constructor on the ancestors constructor, and then does what it's supposed to do in its own constructor, right? So the guidance in C# is if you have multiple constructors, just use constructor chaining, which is what we just did now. Also, this is not nothing to do with the constructors itself, but if you have multiple methods, let's say method overloading, then the argument should be in the same order. For example, let's say I wanted to have another constructor here that is 2 arguments, right? So make and model. I don't want to do this. Or not, I don't want to. You shouldn't do this. You shouldn't have, in this case, it says make model. Over here it says model make. Over here it says make. Right? So you should always have this, but this is make. And this is model. And the orders should not change. So anyway, that's about constructors and member initializers. Now, the area that I got stuck in with constructors was calling a virtual method from a constructor, from an ancestors constructor. Now, this is the way I design classes. Even today in C#, I do this, even though it's frowned upon in C#. In C#, you actually get a warning, and I'll show you the warning. I forget the actual warning since I don't pay heed to it much. Actually, I do pay heed to it. I understand it, and I'm willing to use it anyways. So I'm not saying that warning is useless, and I'll show you why it's a warning or what can go wrong. And of course, once you know what can go wrong, and if you understand that, and if this works for you, you can use it. Just be careful. Make a note of it also as well, somewhere in your source code, because it can cause some trouble. All right. So let's see what that issue is. So what I'm going to do now is in the base classes constructor here, I'm going to remove all the other constructors because it's not like I actually need them. It's just going to make things a little more difficult to comprehend. I'm going to call this drive method. Now, we haven't seen the drive method much here. This drive method itself is not virtual, but the drive method is calling other methods that are potentially abstract or virtual, right? So effectively from the constructor, either directly or indirectly, you're calling into virtual methods. And that's where the rub is. That's where the problem starts or exists. And you can circumvent it if you understand what you're getting into. It's okay to use it. At least I do. I put a note there and also ignore the warning. I think it's not style cop. It's a code analysis warning or something. So I'll actually put an ignore statement explaining my reasoning for ignoring that warning, okay, which is important. The base class is calling into a method that indirectly is calling into virtual methods or abstract methods. So either directly or indirectly, calling a virtual method from a constructor of an ancestor class is frowned upon. Now I'm calling this ancestor class only because I'm really trying to create a vehicle Toyota, not a vehicle base, since that's abstract. And whether I like it or not, that method is going to get called. So let's see what's going to happen, right? So I'm going to run the application again, and I'm going to put breakpoints so we can step in to see, what is going on, so that you're not taken by surprise. And then come here as well. Okay. So I'm going to run this application. And so we are trying to create an instance of Toyota, but it's coming to vehicle base. As we know, it's going to do that. Now I go step, step. Come in here. We are in vehicle base, and in vehicle base, we call start engine, but start engine is abstract, and it's going to jump into Toyota. Now, it's not that start engine is abstract, therefore it jumped into the sense. This is polymorphism, so it would have happened anyways. In C++, the order in which constructors are called is the same as in C#, but there's a difference here. In C++, when you call a virtual method from an ancestor class, it actually goes into the ancestor class's method, right? So if the ancestor class method is implemented, it's going to go there. If the ancestor class is not implemented, you're going to get an access violation. An access violation in C++ or any unmanaged language is really you're trying to access memory that does not belong to you. Right? So it's an access violation. That method doesn't exist, and yet you're calling it. The difference is in C++ that it's going to call into the class in which it is. As it's trying to construct your, let's say your A, B, and C, you're trying to construct an instance of C. But, and let's say B happens to have a virtual method call from its constructor. When it goes from A's constructor, or before running the A's constructor, it goes to the B's constructor, then it goes up to A's constructor, and then it runs all the code in the A constructor. It comes to B, runs all the code in the B constructor. It's going to call into the virtual method in B, but again, it's going to go into a method in B, not in A, and not in C, not the language C, in the class C. So C# is different. The C++ is very different. In C#, the semantics is different from C++. I think it's the correct way to do that, because you're not expecting, you're running polymorphism, or you're intending to use polymorphism. It's a virtual method. It should call into the instance. See, virtual method resolution is based on the instance type, not on the variable type. So I'm creating an instance of Toyota, vehicle Toyota. I expect for virtual methods to be calling into that class's method, not into some ancestor's method, right? So this is expected behavior. Now the problem is when at this point the make is null. It's Honda, sorry, Acura, and 2019. Okay, what if we hadn't initialized this? What if these are more complex objects, right? Not just strings. So let's say you're trying to set it up over here, and you're saying, okay, now I'm going to work. It's all going to work fine. But let's see, these are not just strings. These are some real objects. Real objects. In this case, because I'm using it in the format statement, the null is not giving us a null reference exception, but it would be if it weren't being used in a string concat. Oh, by the way, the string concat also is very interesting. When we look at the IL, next time I'll try and highlight this area here a little bit. Okay, so I've just removed the member initialization code from the base class. They're no longer being initialized, these members, and everything else is the same. The drive method is being called in the base class, and we've set up the member values over here. All right. So when I run this application, it comes to the vehicle base, and then it comes into drive, and then it comes here. And over here, you're going to see that this make is null. Right? Make is null. Model year is 0, and model is null. So these are nulls. And imagine this to not just be used in a string concat, but you actually intended to call a method or something on this reference type, they would be null. So that's the problem. The problem is that you're coming and executing a method in a descendant. Some people actually don't like this in C#, about C#. It's like the ancestor classes have potentially completed, but the class you're trying to instantiate has not yet been initialized because this constructor has never been called. Yet it's calling into a method of the same class that has not been initialized yet. And that's the problem. So in C#, calling virtual methods from a constructor is still frowned upon, is still considered bad practice, or let's say dangerous practice. I wouldn't be so harsh because I actually use this feature a lot. That's just how I think. I like to initialize my classes, and if I'm using polymorphism, then I want that initialization to be different in the descendants, and by simply creating an instance, I can effect a behavioral change. I shouldn't have to call, say, new up this class and then call this one method, let's say initialize. Just to have everything working as expected. So simply calling the constructor of any of the classes, the descendants, I'm getting a behavior change in the initialization itself because the constructor calls the method that is virtual. And so every descendant can implement that method differently. So I get different behaviors. So I actually like that. I use that feature a lot. But if you are using this feature, just make sure you make a note of it. Or I think we should see a complaint here. I forget what the actual warning is in this sort of situation. I guess it's not warning. Well, it's not seeing it. Let me see if I did this. What would it do? I don't think it's seeing it as an issue. I don't know. Oh, there it is. Okay. So what we're seeing now, it says, remove this call from a constructor to the overridable start engine method. I'm not sure what that means. Remove this call from a constructor to the start, but it is a it's not obviously the warning I was looking for, but actually there'll be or maybe I do a code analysis. Is that a control F11? Right. So this is the issue that you want to see here. And what it says is it contains a call chain that results in a call to a virtual method defined by the class. Review the following call stack, blah, 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 blah. Unintended consequences, right? So it's a warning. So they're all showing up the warning. So that's the real issue, if you will. That's what's highlighted. But as I said, if you understand what it is, please document the what and the why, and then use it. But this is where I got stuck when I started with C#. It was just, and I still think in, let's call it the Delphi way of doing things, not necessarily we have given up the hope of having virtual constructors and overridable constructors, but certainly the fact that I want to call virtual methods from a constructor, that issue has not deterred me in using it in C#. I understand what the issue is. And if that issue would occur, I wouldn't do that, of course, but most times I don't think in those terms, and so I don't have that issue. Okay, now let's look at static constructors. There are a few things about static constructors. Let me just define the class so that we can talk about it as well. I'm going to define a class here. All right. So that is the static class. Static classes with static classes, typically the guidance is to not define constructors because constructors in static classes tend to have an issue with performance. So it slows things down, but it's very, very minor, but it's something to keep in mind. Static classes also have, by default, a default constructor is initialized or created for you. And I'm just going to define a constructor here. Now it's not static constructors cannot have, they have to be marked as static, but they cannot have an access modifier. In other words, you can never call a static constructor yourself. The static constructor will be called automatically by the CLR, the common language runtime. You cannot have any code that calls your static constructors. Therefore, they don't have an access modifier, and you cannot assign one. You can't say this is public, even though you know it's public. It's going to complain here any minute now. There it is. It says access modifiers are not allowed on static constructors. You can have multiple static constructors. You can have static constructors with parameters. You can only have this one static constructor, right? That's all you can do. All right. So now over here, I'm just going to say CTOR for static. Right? And what I'm going to do is I'm going to use this here. Let's give this method, this static class a public method. All right. So if I run this application, I'm going to call the method get data. You would say, well, yeah, it's going to run it, but let's take a look at the output. Okay, the output is it's already run the static classes constructor. It's already run that, even though we never actually called it. If you haven't seen so you think you know C# statics or static classes, please take a look at that. I'm not going to go into the detail of that over here, but it's important to understand some of these ideas from that video to even understand this part here. So the static constructor has been called, even though we didn't actually call the static constructor ourselves. The idea is that you don't know when exactly it's going to get called, but before a method of the static class can be called, the constructor will be called. In other words, before you touch the class, the runtime will call that constructor, but you don't know when exactly. It could happen minutes before, seconds before, microseconds before. It's up to the runtime to decide, but the constructor will run for you before you can access or touch that class. The other guarantee is that it runs exactly once in the app domain. All right. Now, with regards to the same static constructor here, what if we did this? What if we had a member like that? And this is a static member initializer. Right? It's static, and we're initializing this member inline. So it's a static member initializer. If you remember what I said earlier, static member initializers will run before the constructor, right? So by the time we call this method here, now it won't change this, but let's see what happens for the member initializer and this constructor in IL. All right. I'm just going to build that. So this needs to be static. Okay, build. And now let's go into IL. Reload the XZ again. And we look at the CC here, constructor. You would expect the member initializer to be initialized. As I said, all member initializers will be run before the constructor, and static member initializers will run before the static constructor. We don't see it here. Well, the reason we don't see it is because we haven't used it. So the compiler's kind of just taken it out. It's no longer part of the code because it's never been used. So let's use it now. Instead of returning empty here, we return data. Right? I'm just going to build again. Open up IL, reload the XZ, and let's look at the CC again. And now you see that this call is there in the static constructor, right? So again, it's running before the code that you had in your constructor. So irrespective of, now let's say, what if we didn't have this static constructor here, right? I said, remember, static constructors can potentially cause some performance issues, a very minor performance issue, plus it only happens one time. So it's not like it's going to be doing a whole lot of things. What you need to keep in mind is, it has an exception because you've written some code, or for whatever reason, there's an initialization going on that causes an exception at the time the static constructor is running. That's going to be you're going to have a bad day. Well, what's going to happen is that that type will never be available to your application ever for that app domain, right? So you've got to shut down your application, start again, and try again. So in other words, it becomes a difficult problem to debug as well. So if you are having issues with your static constructors throwing exceptions, it's going to be hard to figure out how to get it done, of course, depending on the complexity of that implementation. So hopefully you keep the implementations really, really simple so you don't have the chance of having exceptions in your static constructors. The other thing I want to talk about was if you remember, I was saying earlier that if you touch some method or something in the class, the static constructor will run before, right? Before that. With events, not with events, but let's say to an event, you are assigning a static method of some other class and subscribing that to this event. In your code, you can see that this event plus equals blah, blah, and this method, this class is this static class is this static method. You would think that that's where you're touching the method, therefore the constructor will run at that point. That's not going to happen. At that point, it'll run, or for events, it'll run before the event is being dispatched to that method. So the first time that method is by touched, I mean the first time the method is run, if you will, if that makes sense. All right? So that's slightly different from, not like when you look at the code here, as soon as I see this code is being used, it's going to call the static constructor. it actually has to be using that or calling that method, and it only does that for events. It only does that when the event actually is being raised or fired. Right? Okay, going back to this static class here, we remove the static constructor. We still have a member initializer, and we still call the getData method here. So what are we going to get as a result? Any guesses? Null? Empty? You're just going to get the string here. Well, let's see. So first we just look at the output, and then we try and explain it. So if you look at the output, you see it's got the right output. Some of you may not have expected it. Some people may have expected it. So how is it doing that? Well, it's doing it in the same way. If I look at the IL now, again, you're going to find that, let me refresh this. You're going to see that we still have a constructor, right? And it's doing the initialization in here. Anyways, so irrespective of whether you define a static constructor of your own accord or not, as soon as you have a member initializer, a static constructor will be defined for you, and that initialization will occur in the static constructor, right? So don't worry about the performance issue and all that. It's nice to know that, but that's not really important because it's a minor performance issue. The bigger problem is if you have exceptions in the constructor, that's a big problem. That might have to be, sorted out or thought about differently for your classes. All right. So this looks like we've come to the end of our constructors journey. I hope this has been fun. I hope you've learned something. If not, I hope I've just revised for you stuff you've already known. Either ways, these are important concepts to understand. And as a C# developer, which is why I made this video, and my own personal history or experience with C# constructors was something I thought maybe I should share with you because it was something I scratched my head on for a couple of hours or a day or so. It took me a while to rethink or turn my brain into thinking in C#. So if you like this video, please subscribe, please give me a thumbs up, and I will see you next time.